Good evening, City Council members and members of the public. My name is Tim Osting. I'm with Aqua Strategies, and I prepared this information tonight along with my colleague Justin Baker, also at Aqua Strategies. We very much appreciate the opportunity to present this information remotely in this recorded presentation format. I'm going to turn off my screen and share some slides that we've prepared. So what we're working on is the CIP Drainage Improvements Project for Whispering Hollow. And this project has its genesis in the October 2015 event, the Halloween floods that in Buda here in Whispering Hollow caused several houses to flood. This is a picture of the storm sewer system that's been completely overwhelmed, and water is flowing from the houses across the street directly towards the photographer. This is on Bayou Bend Drive, and water was flowing from the south in between the houses towards the north, and then in between the houses along Crooked Creek before the water got into the street and into the drainage area that is on Crooked Creek. So because of that event, that flow event, and because of the poor drainage exhibited on Bayou Bend Drive, we were asked to study the drainage and study the system for its suitability. And the very first step was to determine what we have on the ground, whether what has been constructed was what was planned, and then, of course, whether it was suitable. The city staff have had requested survey from Chaparral, and Chaparral surveyors went out and surveyed levels. So how high are the different structures relative to each other for Bayou Bend and the street, the storm sewer system, this water quality pond, the detention pond, the outfall, and this other water quality pond on the west. So our study will, number one, verify components of the drainage system, and then also, number two, evaluate its suitability across a wide range of events. So smaller events, something that we call like a 2-year storm, all the way up to larger events that occur very infrequently that we would call a 100-year storm or a 500-year storm. And those are easier to say and easier to understand. But now the preferred language is to call the 100-year storm a 1% annual exceedance probability. That's basically the 100-year storm is basically a storm that has a 1% chance of happening any year. And so on the opposite end of the spectrum, the 50% annual exceedance probability is roughly a 2-year storm. So we're going to look at drainage capability of this system across a range of different storms. And we're going to develop some option alternatives to improve the system and to, as best as we can, ensure that it'll protect the residents. This is a map of the drainage areas that drain to this one system. It's a combination of storm sewers and overland flow that route water into our detention pond. This Whispering Hollow Phase 1, this all drains into what we're calling Water Quality Pond A1. And then A1, when it fills, it overflows into Detention Pond A and then goes out of the system into Garlic Creek. All the rest of the area flows into Water Quality Pond A2. When the pond fills up, it goes into Pond A and then downstream also. So the waters mix in Pond A. This is the area of Bayou Bend that's been experiencing some backups. And I think it's important to note the size of the watersheds that we're talking about. There's a significant amount of water that goes through these detention ponds all the way down into Summer Point. Some of the results of the survey indicate that that our structures are either undersized or they are sized appropriately. The detention pond is a little bit undersized by perhaps 10%, and a little bit of earthwork can solve that, can bring it up to capacity. On the ground also, well, in this photo, you can see a little curve in this gabion wall. That's a small thing that can be corrected. But the results of our survey show that generally the system was constructed as it was designed. And so what we need to check is its functionality. This is another area of the system. This is the drainage channel from Pond A out to Garlic Creek. The green lines represent cross sections where we will run a hydraulic model, HEC-RAS, for each of these flow events that I've been talking about, each of the rainfall events. On the left is a photo of the channel in a relatively dry state. I believe that is at Oyster Creek looking upstream, so south, towards the bridge at Crooked Creek. So the bridge you see is at Crooked Creek. And then here's an action shot, water coming out of the storm, coming out of the culverts, out of detention pond A into the head of the channel. So it's looking at this area, water's going from pond A into the channel and then on downstream. This is during that same event, May the 12th, last week. We were talking about the different ponds filling up. And so pond 2 fills up and then it overflows into this drainage channel. That's by design. And this is the end of that drainage channel where it drains into detention pond A. Back in the background, this berm that you see on the opposite side of detention pond A is this side of the wall of water quality pond A2, which is also full and overflowing, as it should be, into detention pond A. So this splitter structure, just as a side note, small things, there's a little bit of erosion around either side, which can be repaired with some earthwork. On Bayou Bend Drive, on that same day during that event, the storm sewer was backing up again. And this photo illustrates, this is storm sewer G, which is on the south side of Bayou Bend. This is the same storm sewer with the truck driving through it on the south side. Water, when the street fills up to capacity, when the water level is to the top of the curb, water flows across the top, and then when water's high enough, it can cross over some of the driveways and into the yards on the north side of the street. So what do we look at? And how do these storm events factor into the level of storms that we plan for and the level of storms that we had historically planned for? This table represents two different design criteria. And when the subdivision was designed several years ago, the original design criteria, we'll call out the 100-year events, the 1% annual exceedance chance. The design criteria was for 10.2 inches in a 24-hour period. There's been some new guidance from NOAA. It's been a long process to develop new statistics around rainfall, and but they've done it. They started some time ago, and they actually ended up extending their deadline so they can include some of the more recent events like the October 2015 event, and they also included Hurricane Harvey in this new set of statistics for all of Texas that they call Atlas 14. And so Atlas 14 is the new standard for design criteria for rainfall for designing drainage structures like the one we have here in Whispering Hollow. So one of the things to note is because more recent events have been added and because more recently we've had larger events than historically, these design criteria have increased. So with an increase in the rainfall amounts, we're going to have an increase in runoff, an increase in drainage capacity is needed. So part of our study is to study whether or not we need to increase the capacity of the existing system here in Whispering Hollow for the maximum flood events. Um, so to put that 13 inches in context for the 1% event, we look at the October 30th event, 2015, and the 24-hour total was 13.25 inches, which is on par with this number we see here. However, we look at a few different things. One is not only the total rainfall over 24 hours, but also the total rainfall over smaller increments. So the intensity of the storm over 2 hours actually saw 10 inches over 2 hours. And this is this orange line here. And this represents every dot is 15 minutes. So we had several minutes in a row, or several 15-minute periods in a row, where there was more than an inch in 15 minutes dropping to the ground. So that was a very high intensity event. And if you look at the intensity rather than only the total rainfall, it's more like a 500-year event. So that was a very significant rainfall event that happened. I'm not surprised that it overwhelmed the system that wasn't designed for it, nor did anyone intend for it to be designed to manage that capacity of flow. More recently, the green line here, that was the May the 12th event last week. And there was a couple time periods where there was very intense rainfall. We had this in 15 minutes, 1.2 inches of rain fell around 10:45, 11 o'clock. And the photographs that I showed earlier were from around 12. So it was after some of the most intense rainfall had already occurred. The blue line is from April the 3rd, when the storm sewer also filled. And so in a 2-hour event, we had roughly 2 inches of rain. So both of those recent events from the last month or so stack up more like this 2-year event. So one of the things we're doing to evaluate the system is developing a model, the storm sewer model, in addition to that open channel model that I mentioned earlier of the drainage out to Garlic Creek. The storm sewer model, this is one schematic of it. This is the top of the curb. This is Bayou Bend, the street level roughly, and this is the size of the storm sewer underneath the ground, underneath the street. So when we run the April 3rd event through the system, we predict a maximum water level that does in fact exceed the street level and almost gets to the top of the curb. So what this means is we have a tool that mimics the system, and we're also able to predict what happened. And so that allows us to identify what is the choke point and what is the problem area. And it's this concrete weir we noted as F. It's the concrete weir in the cul-de-sac near the mailboxes at Bayou Bend. So this is F. This is that splitter structure I was talking about. This is it. There's a little weir on the inside. This is a photograph of it at the same time as the earlier photos, which showed the pond full and the channel flowing into the detention pond. So this pond was full, and this pond was full A2. Water underground is stacking up and going over the weir down the channel into the detention pond. But when water stacks up underground into this splitter structure, it also backs up to G. And because this is a low area in the street, water there's only about 1.25 feet in between the top of the splitter and the top of the curb. So what we've seen is that's just not enough. So a few preliminary potential solutions we've identified as we're in progress with our study. Number one is that for frequent events, the 50% recurrence, we really need to improve the conveyance of those smaller storm events. And we're going to need to reconfigure the water quality pond A2 and its connection to the detention pond to reduce backwater flooding. The infrequent events, the 100-year storm, we may not be able to completely capture and prevent flooding under the same thing that happened in October 2015. But uh, for a 1% annual chance, that is what we are aiming to be able to capture and be able to convey through the system without causing any substantial flooding anywhere. And in order to do that, we'll have to reconfigure that splitter box. And there's other options that we can consider as well if we need more volume, increase the volume of the detention pond, lower the outfall of the detention pond, and as I said, reconfigure the water quality ponds. There's other minor issues that we've identified that I pointed out, the gabion wall and some minor erosion. So as we identify these, we're cataloging them and moving them, evaluating what to recommend. So again, we're looking at the end of May to have a report on choke points, deficiencies, opportunities. Sometime in July to develop alternative options, and sometime at the end of summer to have construction plans available so that construction can start in the fall. The last thing I wanted to talk about is that the city was very interested in providing some short-term emergency solution to the flooding that's happened on Bayou Bend. And to do that, they have lowered the elevation of the outlet for the water quality pond that we were talking about, A2. And this is just a map of what's been done out in the field. The berm has been cut to allow water to escape before it backs up and fills up that splitter structure and backs up the storm sewers. So with that, I'll stop. Thank you very much. We very much appreciate the opportunity to present this remotely. We appreciate the opportunity to work on this important project in Buda. Please give me a call if you guys have any questions. Thank you.